Welcome to this deep dive. Today, we're looking at a fascinating stack of intelligence briefings marking exactly 10 years since AlphaGo made history. But our sources aren't really looking backward.
Right, they are completely focused on what's happening right now.
Exactly. We're unpacking this massive industry shift we're going through, transitioning out of generative AI and moving straight into agentic and physical AI. So, systems designed to actually execute complex workflows and navigate the real world.
It's a profound pivot. I mean, we are basically bridging the gap between those isolated experimental algorithms of the past decade and the autonomous physical systems of the future.
Yeah, and to get us started, the briefings highlight two completely different approaches hitting the wire at the exact same time. So OpenAI just released GPT 5.4, pushing this staggering 1 million token context window.
Which is massive.
It is. It lets the model process absolute mountains of text all at once. But on the flip side, we have Jan LeCun's new venture, AMI, which just raised a $1.03 billion seed round for what they're calling world models. What's the fundamental split here?
Well, we're seeing what's being called a great divergence in how we build intelligence. So for years, large language models achieved incredible things simply by predicting the next logical word. But there's a growing consensus that this approach is hitting a linguistic ceiling.
Because words only describe reality.
They don't encompass it. Exactly. AMI's world models are attempting to teach AI to simulate physical reality, to understand gravity, momentum, and cause and effect. It's a much harder problem than predicting text, but it's the mandatory next step if AI is going to interact with the physical world.
So to actually simulate cause and effect, I imagine that requires just an unbelievable amount of computing power. The sources detail what's being called the Nordic migration. It seems traditional power grids just can't handle the strain.
No, they really can't. The energy requirements are enormous. Tech companies are being forced out of traditional tech hubs and into energy-rich, cold climates.
Like Niscale securing $2 billion to build a 100,000 GPU facility in Norway specifically for OpenAI.
Yeah, they desperately need that region's abundant hydroelectric power and the natural freezing temperatures just to keep the servers from melting down.
But even with cheap hydropower, how is running these models economically viable at a global scale? I'm guessing that's where NVIDIA's new Rubin architecture comes into play. The notes mention it's cutting inference costs by 10x.
Precisely. Inference cost is the actual computing power, and therefore the money required to run the model every single time you ask it to do something. Dropping that cost by a factor of 10 changes the entire business model.
So all this cheap Nordic-cooled computing power isn't just for building better chatbots anymore.
Right, it's the engine required to run continuous autonomous AI coworkers that operate 24/7.
Which makes OpenAI's recent acquisition of this security startup PromptFu make perfect sense. They want to stress test these AI coworkers before letting them loose on a company's internal data.
Definitely. But the new Anthropic Labor Report has some wild stats on the reality of this rollout. Theoretically, AI can cover 94% of professional tasks in certain fields, but actual usage is hovering around 33%.
Wow. The corporate adoption is lagging, but the economic impact certainly isn't. Even with that usage gap, entry-level hiring has already dropped by 14%, which creates a fascinating problem for you to consider, this idea of talent debt.
Right. If an AI is doing all the junior-level documentation and grunt work, how do human beings ever get the foundational experience required to become senior experts?
It's like relying so heavily on GPS that a whole generation forgets how to read a map. That is a wild bottleneck to think about. And these agents aren't just staying on our screens either.
No, they are not.
Qualcomm and NURA Robotics are partnering to use the Dragonwing IQ-10 processor as a standardized brain for humanoids.
It's essentially the Android moment for robotics. We are moving cognitive robots from custom laboratory projects into standardized, mass-produced machines for industrial and domestic settings.
But with AI entering the physical world like that, how are regulators possibly keeping up? Looking at the raw data, the rules are all over the map. Impartially speaking, the U.S. federal government is actively preempting fragmented state laws to force a consistent national network.
Meanwhile, the EU is banning emotion recognition technology in schools, while simultaneously easing up on their AI training rules just to stay globally competitive.
It's a complex web. But for you, the core takeaway from all these briefings is that the tools you use are no longer just answering your questions. They are being given the autonomy to take actions, manage your workflows, and interact directly with the physical world around you.
That is the massive shift right there.
And as we look at massive cloud centers in Norway and standardized robot brains, we want to leave you with a final thought to explore on your own. Consider the impending rise of small language models, or SLMs. What happens to all these giant data centers and debates over data sovereignty when your phone or your personal drone can run ultra-compact GPT-5 level reasoning entirely on your device? Imagine having all that power and autonomy without ever sending a single byte of data to the cloud. Thanks for joining us on this deep dive.